Okay, lab number 5, final lab for the course. It just posted before the class. So I would suggest you try to do that as soon as possible. The due date is before the project. It's the intentional. So hopefully you can finish that before the project. Just plan your time well. And for the project, if you got any difficulty of finding your partner, please write me an email or just get in touch with me. I'll try to find partners for you. Okay? And for your lab test next Wednesday, I'll try to make it straightforward for you. I already completed some example tests and also some study guide. I'll release them tonight. So you can have a look at them, study them, and hopefully you can be very ready for next Wednesday for the lab test. Okay, let's just review what we said about observer pattern. Okay, again, let's always learn from the not so perfect design before we try to learn about a good design. Eventually, for this lecture here, we'll learn about 3 kinds of design. Okay, 3 kinds of them. The first one, as we said, is not very good, simply because, let's just review very quickly why it is not so good. You can see that the client supplier is one directional. You can see we got forecast, we got current conditions, we got statistics. Each one of them is observing some part of the weather data. For example, for the case of forecast, you are observing just the pressure. Okay? In the case of current conditions, you're observing temperature and humidity. And for statistics, you're observing just temperature. There are different parts of the weather data. And the important thing is, every time before you try to display over here for each one of them, before you try to display, you're simply not sure if the data you're keeping track of is the really most up-to-date. That's why you want to make a connection to the server. So that is why you got weather data, and weather data over here. Okay? And for weather data, you also got the 3 attributes over here, and also the variance. Right? That's the first design. The main drawback for this particular design, as we discussed in detail last time, basically is every time if you want to display on the app screen, you have to make an explicit connection to the server of the weather data, and then get the most up-to-date data, the most up-to-date value. And computing resources, especially the bandwidth, can be wasted if maybe there was simply no change on the weather data just yet, but you're still making the explicit connection. So it can be a waste of resource. That's about the first design. Okay? So the second design, which is the so-called observer pattern, it improved this by adding another direction of the client supplier. Basically, you can see that at this particular design, we only get a direction from app to the weather data, okay? Which means you can only make a request from one direction. So this observer design is trying to improve this by adding another direction over here. Basically, it is to say every time if the weather data has any change, it's going to cause the forecast, for example, let's say this. The second design, which I'll show you in just one moment, the second design is going to work in the following way. Every time if there's any updates, let's say on the weather data side, if there's any updates, the update is going to first of all follow this direction over here to say, now for the forecast app, now you must do an explicit updates for now. Okay? And then it's going to do an updates accordingly. Okay? It's only updates on demand when there's really a need for the updates. Okay? That's going to be the observer design. Let's see exactly how the observer pattern works. Okay? So now, observer pattern work in general, it's just a design pattern. So on this page, we're going to see how it works in general. And in the second page, we're going to see how we can apply that to our weather station problem. Okay, let's see the first one quickly as a review. There are 2 terms you have to be aware of. One is called subjects. The other one is called observer. Okay, subject is like weather data, something that's being observed. And observer usually is multiple observers you have. They observe the data. And for the subjects, you have basically a list of observer. And we talk about polymorphism over here. You can see observer over here is the static type for each member in the list, right? And given that observer is simply a deferred class over here, you may have as many descendant classes as you may like. For example, forecast, current conditions, and statistics. So that means dynamically speaking, this list over here will be polymorphic, right? That means it can be any observer that's descending class of the observer here. And then this notify feature is the most important one. This notify feature is going to say every time if there's any updates on the subject side, it's going to notify every observer that's currently in the list. Okay, that's kind of the idea. And every time when you notify the particular observer, the observer is going to update their current data that's being observed. Okay, that's about the general pattern. Okay. As far as this general pattern is concerned, you just have to know, first of all, you have a subject, you have an observer, and then you have a client supplier over here. So you got a list of observer, and also you may have many different descendant classes of either subject or observer. Yes? Yeah, so good question. The question was, so what do I really mean when I say attach and detach over here? Basically, again, this a green arrow means client supplier. Client supplier can be usually from either of the three scenarios. It can be you try to declare the type of a feature or like attributes, right? Like in this case, it can be just observer, right? That's one scenario. Second scenario, if you're trying to use the type as a parameter type, or you're trying to use it as a return type. So in this case, let me highlight it to you. So when you have something attach and detach, this is something you will see in just a moment when you see the, okay, let me just say this specifically. So that means in the subject over here, we have a feature called attach. And the attach is simply just going to have O of type observer. Okay, this is what you have. So that means observer is simply the type you're trying to make use of. So that's also a supplier, in this case, observer. We just choose to see which features you want to put on the arrow. Okay. Of course, if you want, you can also put observer over here, observers, and then you can say list, and then we can say dot dot, right? As we said before. That's also fine. Just say for this particular example, I just want to emphasize on attach and detach. Okay, attach and detach are simply like add and remove. Yeah, we'll get there. Yes. Yes. Sorry, speak up a little bit. The third one. Return type. Huh? Let me hear his question first. Could you speak up?
What is the third scenario?
Okay. Again, client supplier. Can I just make this clear to everybody? So we talk about client supplier, okay? So client supplier. Okay, there's three scenarios. Let's say this is, let me make it very clear to you. This is the supplier class, P. And let's say this is the client class. Let me just call it C for clients. Okay, so there are three scenarios. Either I'm trying to declare the attributes A of type C. Okay, second scenario, I can have a command. It doesn't have to be a command, just any feature. I don't want to confuse you. Let's just feature one. Feature one, which will take some parameter of type C. That's also a client supplier. Okay, it can also be, sorry, I'm running out of space, but it can also be F2. And F2, let's say, takes no parameter, but it returns a type of C. That's a third scenario. It can either be a type of the attributes, it can be the type of the parameter, or it can be the type of the return value. Either of the three cases, you will have a client-supplier relation.
What about the local variables?
You don't typically show local variables because local variables are hidden from the feature. Okay, typically you don't. Okay, so now in this case, you got either of the three scenarios, you can simply have a client-supplier relation over here. Okay, you can simply put you can put attribute A, feature F1, and feature F2. So all three cases are client suppliers. But of course, in the bound diagram, you don't necessarily have to show all the client-supplier relations. Just choose, be selective. Okay. Okay. Any question about the general pattern over here, about observer pattern? Okay. Let's now be more specific. Let's try to instantiate this particular observer pattern into weather station. Okay. Let's see. You will see exactly the bidirectional arrows over there. Okay, this one we also went over last time, but let's go over architecture again, and then I'll show you how you can implement this programmatically. Again, we got two clusters here. We got subjects and we got observers. Okay, and for the subjects over here, so the subject is just the same as before. So we got observers here, which will be a list of observer. So what kind of observer do we have? In this case, we got observer here, which is deferred, and we got either forecast, current conditions, or statistics. Dynamically speaking, observer over here can be either forecast, current conditions, or statistics, right? It's polymorphic array, okay, or polymorphic list. And then this notify over here is going to make sure every observer that's currently in the list, or all the subscribed observers, are going to be notified. Okay, we'll see the code to see how to do that. And you will see that for this particular weather station problem over here, the subjects we have is called weather data, right? Because weather data contains the temperature, humidity, and pressure. So these are the three values being monitored or observed by all the observers. And then you also got some invariants over here to say what the correct limits are for the three measures. Okay? Okay, any questions about this particular one? Oh, before I say one more thing. So we got attach and detach as before. Now, over here for forecast, current conditions, and statistics, they also got another client supplier arrow over here for each one of them to the weather data. Okay, we simply call it WD. So which means there is an attributes in forecast, in current conditions, and also in statistics. Simply, you just say WD of type weather data. Okay, you will see something like that. Again, as from one of your questions before, how can you judge to see client-supplier relation? Either type of the attributes, type of the parameter, or type of the return value. Okay, just always keep that in mind. Are we okay with this diagram here? Okay, let's now see some code. Okay, that'll be for the observer pattern. And then we'll criticize on that and see how we can go from the criticism to our final design. Okay, let's have a look. What I will do is let's observe a pattern over here. It's typically one to many. Let's say for the case of the weather station, one particular weather data instance, but we got many observers, right? We got 3 observers in this case. Okay, so these are some terminology for you. So whenever you want to add an observer to the subjects, you will say subscribe, or you say attach, or you will say register. So these are just the terms you can get used to. Okay. And also, you can also remove the observer from a particular subject. You will say unsubscribe, detach, or unregister. Okay. And every time if the subject wants to publish or want to give some updates to all the observer, you can say it's publish, or you can say it's notify. Okay. So feel free to use any one of them. Okay. And also, whenever you want to update a particular observer, you will say either handle the updates or just update. I think update is more common. Okay, let's now see some code together. Okay, I'll show you the code line by line first of all. Okay, and then I'll show you the big picture. Okay, let's go that way. Okay, let's see. Let's have a subject over here, right? Subject is going to be, for example, the superclass for the weather data. And for the subjects, first of all, we got observers of type list of observer. Okay, you wouldn't put just forecast over here. In that case, the static type will be too restrictive. You want to be as general as possible here. Okay, and then you have the make feature over here, the constructor. And over here, we simply just want to make sure initially, when you first create these subjects, like a weather data, there's no observer just yet. So how would you write this post condition over here? Yeah. Basically, either the count is 0 or it's empty, right? Okay, your observer's account will be empty. Okay, that's easy. So now let's just do one together. Let's say I want to attach or I want to subscribe. Let's say let me just use attach and detach words. Attach is going to add a particular observer over here into the list. Okay, so now what should be the precondition? The precondition, let me give you a tag, not yet attached. So what should I do over here? Yeah, you may either use across, and then across you want to make sure none of the existing observer is equal to O. Or you can just call the library feature that's already declared on the list, right? Either way. Okay, I can simply say, not the case, observer.has. Well, I just got the feature already, so you can just use that. And then ensure will be the opposite. After the feature call, you'll just make sure observer does exist. Okay, that's about attach. Very simple contract to write. And detach will work in a symmetric way. Detach simply means I don't want this particular observer to observe my data anymore for this particular subjects. So I would say the precondition will be the logical negation of the attach. So that means if you want to detach a particular observer, you better make sure that observer currently is there. Okay, so you would say it's there. Okay, observer.has. What about the post condition? Well, after detaching this particular observer, you want to make sure it doesn't exist there anymore, right? So you would say, okay, it's not there anymore. Okay, guys, any question about attach and detach? Okay, just keep in mind for the subject, it's very easy. Either add a new one or delete the existing one. So now notified. This one is interesting. Okay, the idea about the notify is I put informally there. You want to notify each register or each attached observer about the updates. So that means I want to go over each of the observer in the observers list. That's what I want to do. So what kind of feature can I call on this particular observer before you see the code? Okay. Now, let's have a look at the architecture. Okay. If you go back to this diagram over here, oh, sorry, not here. Okay, that's our observer pattern over here. So now, what feature can I call? Basically what I want to do is, I want to say, I want to go across the observers for this particular subjects. You can say across observers as some cursor, right? And then I'll do some loop. But inside the loop, what kind of feature can I call on each observer? According to the diagram. Yeah, what can I? Yeah, apparently you can see there are only two features over there that you can call from the observer side, right? Because we know that the static type for this list is simply observer. So you cannot call any descendant specific feature. You can only call whatever that's defined at the superclass level.
So the rest of the two features that observer has, would you say that if you have to notify all the different observers, you just...
It didn't really say that. Basically, as far as the observer is concerned, you just want to make sure whenever, you don't really, okay, here's the essence for observer pattern. The observer themselves do not initiate the update themselves. It's only the subjects that actually call the update feature on the observer. So they are just waiting there.
How would you know
When to call updates, you will see that. That's exact.
up-to-date with subject?
You can think about update up to date with subjects is more like a post condition predicate you can use, but you will see. It's just Boolean predicates, right? So updates and up to dates, they work together, as we will see. Okay. Okay, let's now go back here. So we agree that given that the static type for each element in the list is observer, you can only call either updates or up to dates with subject, right? That's what you will see. So now if you go back to the code here, what a notify will do is you're going to say go across the observers as cursor, cursor.item.updates, right? Now, can anybody try to explain to me this particular line? Where is dynamic binding going to play at the runtime? Which part? Okay, go ahead. Update, right? Can you be a little bit more specific? Okay. Basically, thinking this way, conceptually. Let me sketch very formally, and we'll see some more specific example. If you think about any particular, let's say the weather data. The weather data simply just get a list of observer. Let's say this is the observer array or list. And then at the runtime, it's simply polymorphic, right? So maybe the first observer for this particular subject is simply forecast. I'll put F over here. And the second observer is of type current condition. I'll put CC here. And the third one is simply statistics. Okay, so when I say observers, let's say at position 1 or any position I, let's say any valid index, dot updates. We know that the update feature at the observer level is simply just deferred, which means it is not implemented. At the runtime, we have to know which version of the update to call, depending on the dynamic type, right? So now, if I is simply equal to 1, that means we're going to call the update feature on the dynamic type for the first element in the list, which is the version in forecast. If I is simply equal to 2, that means we're going to call the version from current conditions and etc. Right? That's how the dynamic binding works. Guys, make sense for this? Okay, yeah. Yeah, that's exactly what I meant. So if you look at that over here, you can see it is the subject itself that actually initiates the updates, but not the observer themselves. So the subject, every time, you want to make sure you only notify when necessary, right? And then you will see that now, how can we use the other feature in the observer? Remember, there was another Boolean query over there, which is called up to date with subjects over here. Okay, over here. So that's how we actually specify the post condition for the notify. We say that after notifying every subscribed observer, we're going to have the following. That basically we say all the observer over here, you can see that's just another across loop. Across all the observers over here, and then all the item, which is the particular observer we're talking about, dot up to date with the subjects. Again, if you look at that, this particular up to date with subjects feature is deferred at the observer level, right? You can see the star over here. That means depending on which particular observer we are talking about, it is going to call that particular version. Okay, so we're going to see 3 different versions for up to date with subjects in just a moment. So far we only talk about subjects, not the observer just yet. Okay, now let's now have a look at the subjects. Okay, so this is only the subject in general. What about weather data? Remember, weather data is simply just a subclass of the subjects, right? So now let's have a look at that. So what we have is inherent subjects, and then let's say we simply rename the constructor from the previous one. Just say rename, make subjects. Okay. This one here, you can just go over the code. It's not really that important for, conceptually. And then for the weather data, we simply declare all the variables that are going to be observed: temperature, humidity, and pressure. Okay. And then what it really means to be for the limits of the 3 measures to be correct, right? As we said before. Now, for the make feature here, we're going to make some initial temperature, pressure, and humidity. Just create the subjects, which will create the empty list of observers. And then we'll simply set the measurements, right? So far, so good. Now, what we have to make sure is every time when you actually try to call set measurements presumably is going to change the value for the measure, right? There's going to be some updates. The consequence of having set measurements is you have to update every subscribed observer. Okay? That means we have to internally call the updates for every observer. But how do we do that? Well, easy. You will simply say, you will see the code. Here, we want to say before you can set the measurements, you simply require that the limits are simply correct. Okay? And then also invariant to say the limits are correct. Okay? There's some code I really didn't show you for the do and embody because they're kind of trivial. So you can refer to the code I'm going to post for you. Okay? Are we okay with the subject side? We talk about subjects and also weather data, but now we're going to see the observers.
It's not enough to have the invariant. Is that you also have to have it required?
Which one? You're you mean the correct limits? So this one simply say the temperature, for example, must be between maybe minus 100 and plus 100, right? Something like that.
So it's not enough to have that justification invariant. You have to have it as a precondition as well.
Yes, because we want to make sure the precondition is strong enough so that if the precondition is satisfied, it would violate the invariance. Yeah. Yeah. Actually, that's something to do with the next subject, maybe later this week, when we talk about how you can prove that your contrasts are appropriate. Yeah, that's something we'll get into. All right. Yeah. Okay, so what we have done so far, we have done the subjects and we have done with the weather data. Okay, let's see how we can do observers and the 3 observers over here. Okay, that'll be the other half of the picture. Let's see observer first. For observer, basically very easy. Let's see what we have to do. So we have to say, first of all, up to date with the subjects, but at this level here for observer, at this level, we simply don't know what kind of observer you're talking about. So the updates and also up to date with subjects will just be deferred at this level. Okay, but we'll make it effective at the descendant class level. That's what we'll do. Okay, let's see over here. Up to date with the subject is deferred, and also update itself is also deferred. The only thing we can do is to say ensure up to date with subjects and up to date with subjects. And remember we talked about subcontracting, right? Now you can see that over here updates has a post condition there. That means it will be inherited to every descendant class of the observer. It will be combined together using conjunction, as we said. Okay? Okay. Now we're just going to see exactly how we can define these 2 features for every descendant class for the observer. So let's see forecast, current conditions, and statistics. That's how we're going to implement them. Okay, let's see one of them so you will get an idea. So the other 2 will be defined in a very similar way. Now, let's see. Let's do the forecast. Basically, forecast is going to just only to observe the pressure. And if the pressure is has reduced, that means it's likely to rain. Okay, as we said, only the pressure is going to be observed. Now let's have a look. Well, the forecast inherits from observer, as you can see. Forecast inherits from observer over here. And then we have the make, which will make a link to the weather data. Okay. So now, question for you. The constructor for the observer might be the most complicated one to really get right. Okay? Let me give you a little bit of hints. You can tell me what code to write. Basically, you can think about it in this way. We are talking about how to create an instance of the forecast observer. Okay? So there are 2 things we would like to achieve. Number 1, we want to make sure, well, one more thing to show you, just keep in mind. The parameter that we are taking for this particular make, we have a weather data, which is the subject, right? So we're talking about, we want to create an instance of this class given a weather data. So these are the 2 things we are given. Okay? So there are 2 things we would like to achieve. Okay? I'm highlighting in blue. Number 1, we want to make sure this particular weather data will be attached to this particular, we want to make sure, first of all, this link will be established, which means this forecast should be added to the list of observers for the weather data, number 1. Number 2, we want to make sure also forecast is also now pointing to this particular weather data as well. So there's a bidirectional link. So how can we achieve these 2? Okay. The number 2 is actually easier. Okay, over here you can see that in order for the forecast to actually pointing to the weather data for one direction, that one there, simply we already declare a weather data attributes. You simply assign WD to be whatever input it is, the weather data. Okay, now how do we add this particular instance of forecast that we are creating into one of the observers in the list? How do we do that? Is there any feature we just talked about that we can call? That's a question for you. Okay, I heard some nice word. Okay, let me just make the context more clear to you. Okay, we'll talk about this particular one. Okay, and then we talk about the make feature, the make, and then we simply got WD, which is of type weather data. Okay, that's a make feature we talk about. Now, how can we make sure this particular object is being added into the list of observers? And we do have that feature defined already, right? Because WD over here is of type weather data. Weather data is simply defined over here. What feature can we call on that to add the observer? Which feature? Notify? Or attach? Maybe attach, right? So I can say WD dot attach. Attach what? We want to attach the current observer that we're talking about, right? So say current. In Java, it's like this. Okay, so we just say current over here. Okay, very good. So that's how we achieve one of them, current. Okay, that's exactly what you will see in the constructor here. So you would say weather data is assigned to a weather data. That's one direction, right? So this first line we just see over here is basically making sure forecast is now linking to the weather data, one direction. The other direction is by simply say weather data that attach current. Okay, that makes sure this particular weather data is going to attach this particular forecast over here. That's why we got bidirection. So you want to make sure in the constructor for the observer, for each one of them, you actually establish this bidirectional links. Okay. Hopefully, I will show you a test at the end. So hopefully everything will work together. But let's just go over the code very quickly. And then afterwards, you will just make sure weather data is weather data, right? One link. And also you can make sure the observers for the weather data contains the current, right? You make sure both links actually work. Any question about the constructor here? I would say that's the most important feature for the observer, okay? And the make feature for all the other two observers will be very similar, okay? You always want to make sure not only that the observer is pointing to the subjects, but also symmetrically the subject contains the observer as well, okay? Bidirectional. Okay, let's now go on a little bit more. Now, what does it really mean to be up to date? Remember, up to date used to be deferred at the observer level. But now at the forecast level over here, we would like to make it concrete, make it effective. Well, it's easy. You simply say, ensure the pressure is simply weather data the pressure, right? That's when you actually try to make a connection to the server. Okay? And now, let's say also, how do we do updates? The updates, I didn't really include details for you, but I can refer to the first design. For the update, simply just try to update the, just go to weather data, the link, and then try to get the pressure level. Okay. Okay, you can also display. One thing to note, when you study this particular pattern, notice that the fundamental difference between the observer pattern and the first design. In the first design, remember always in the first line of the display, we always have to say updates. But now we don't have to say the updates anymore. The updates is only initiated from the subject side. So the subject only calls the updates on the observer when necessary. Okay? Guys, are we okay? Okay? The complication about observer pattern is not about the individual feature. It's really about how everything works together. Okay? But we'll see a test in just a moment. Okay, that's about the forecast. Okay, so now let's go. The current condition can be defined in a very similar way. Okay, so what we just talked about was the forecast. Okay, let's talk about current conditions and also statistics. They're done in a very similar way. Sorry, it's a bit small, but I'll highlight it to you. Okay, because I want to put everything together. All I want to show you is you can see that the make feature, make and make. Okay, the make feature for all the three descendants of the observer, they do this. They try to achieve the same two tasks. You can see number one, they want to make sure weather data is assigned to the input weather data. Number one, and then you want to say weather data, which is descendants of the subjects, also attach the current objects, and do the same thing for the other one as well. Attach the current. You may do that, but I'm just trying to show you the two steps. If you really want, well, I would say separating these two steps is clearer. Yeah, you want to establish two links basically. Yeah. Okay, any question about this? So we talk about basically observer and the 3 descendant classes. Okay. Now what's left is how to put everything together. Okay. And that'll be the next slides. But before that, any question? Yeah.
Professor, so what is the main problem that the observer pattern is trying to solve? Like the design pattern that it comes in.
Oh, actually, so you're asking what's the limitation for observer, right? That's something we'll get into. But let's make sure, but pretty much you know that why observer pattern is better than the first design, right? Because we got bidirectional link. So the update can be initiated from the subject side rather than from the observer side, right? That's why observer pattern is better. But now, let's make sure we understand exactly how that works before we talk about the limitation, okay? Okay, so now let's go over some code altogether, okay? Let me show you the code first and then we'll visualize it, okay? Okay, so I'm just going through. So now let's say this. So this is gonna be a test code to put everything together. Let me just go over with you the overall picture and then we'll see the visualization. Let's say we got the 3 apps. We got current conditions, we got forecast, we got statistics, and then we got weather data, okay? And then, so we got 3 observers, we got 1 subjects. Basically, what I'm gonna do is I will initially create the weather data, the subjects, with this kind of measure. So temperature being 9, pressure being 75, and humidity being 25, something like that, okay? So initial measure, and then I will simply say I will create the 3 apps over here, and with the subject being the parameter to the constructor, right? After that, I will try to say I will now change the measurements for the weather data, which means there's some updates. And the way to really notify is by calling wd.notify, right? Okay. After the notify, I would expect every observer should have been updated after this feature call. And then I will simply say display. And now this display over here should really display the data based on the latest measure over here, right? The measurement. And then I can, and now what about, okay, now, can you just tell me for 12 and 13, right? 12 and 13. In the first design, I deliberately make the 2 test code very similar between the first design and the second design. In the first design, between 12 and 13, there would, every time when you call display, there will be an explicit updates initiated from the observer, right, to the subjects, right? But now in the observer pattern, the update is not initiated from the observer anymore, right? So that means for 12 and 13, right, there's no 12 and 13 over here, there's no updates that's required anymore. The update is only done in line number 11, okay? And then, let's say we set the measurements again. So now what should we do first? Well, we should definitely notify and then do the display. Okay? That's only about the overall picture. Let's visualize it, see how things work together. Okay, let's now go to, okay, let's see how things work together. Yes? Could you speak up? I cannot hear you. Which one twice? You mean over here? Why do I call it twice? Well, simply because maybe internally, well, you know, for the app, it may not just keep the display always, right? It has to periodically refresh its screen to make sure it display the latest data. That's why maybe after 5 seconds, you want to fresh up your display for the app. That's why you call cc.display twice. Well, that's kind of the end of the test. I'm just trying to show you over here, right, for 12 and 13. Okay, basically over here, what we have is between 2 updates over here, you can see line number 10 is the first updates. Line number 15 is just another updates, right? Between the 2 updates, you want to make sure you always do a notify first to make sure you notify all the observers about this particular weather data. There's an updates. And then the notify will make sure every observer is updated. And then before the next change, you can simply call display for as many times as you like. Okay? Questions? What do you mean notify fails? What do you mean?
So let's say that like you're doing this over like the internet or something.
Yep.
And then
So you're more talking about if there's any network failure, right?
Yeah.
Okay. So what we are talking about here, we have some assumption here because that's kind of beyond the scope of this particular course. We're only saying that assuming that the network traffic is going to be safe, and then always if you want to notify from the server, from the subject into the observer, it's always going to be carried through to the observer without any failure. But once you carry it through to the observer, you want to make sure the post condition is satisfied, right? Yeah. Having any failure on the network traffic is beyond the scope of this course, so we don't have to worry. Okay? Yeah. All right. And also, network traffic is not really part of the business logic, so we don't have to worry about it, right? Okay, let's revisit this fragment of code and see how things will work together for the observer pattern, and then we'll criticize a bit. Okay? Let's go line by line and see what happened. Okay? Now let's go on. Let's see. For this particular line, we say creates wd.make 9, 75, and 25, right? That means we got wd weather data objects. So we got 9 temperature, 75 pressure, and 25 the humidity. And initially, the observers is simply just empty. Let's say just empty initially. Okay, no observer just yet. Now, the most critical line that you have to understand is this. Let's say this. When I say creates a current conditions objects, so what does it really mean? Okay, this is the part you have to understand very well. The current condition class is over here. Okay, it's one of the observers. And the make feature we are calling is over here, right? And the parameter we are passing is simply WD. The reference is called by value, right? WD. And WD is simply going to replacing this particular parameter, just going to be WD, right? So now, how do we understand the execution of these two lines? How do we understand them? Okay, let's try to see. The first line, let me use green. Weather data is assigned to a weather data. A weather data is simply just WD, the input over here, right? So now, basically, we're talking about CC over here. That's a context objects. So CC is over here. So that means weather data is the attributes is going to point to wherever WD is pointing to. Agree for that line? Are we okay with this line? That's a green one. Okay, let's do another one. Another one is going to be over here. When we say weather data, in this case, is simply just WD. We're basically saying WD.attach current, right? Current in this case is simply just CC that we talk about, right? It's like this. So that's simply just CC. So that means that's effectively saying CC, that's effectively saying WD dot attach and then CC. It boils down into that particular line, okay? This somehow is similar to how things work for visitor pattern, if you try to recall, okay? Just as a remark, okay? Now, if I try to do WD.attach CC, that means I'm gonna add the CC over here as one of the observers. So that means, in this case, simply just empty to begin with. That means it's going to be, the first observer is going to point to this particular app, right? Bidirectional. Guys, are we okay with this? That's the most important line to understand, how the bidirectional links are established. Okay, let's do one more. We're going to use a different color. So let's say I use pink over here. What about this particular line? When I try to create another observer object, in this case, just forecast. How do I do that, right? Similarly, for the forecast class, also the make feature also got these two, right? And now given that I'm passing the same reference of WD, right? It's going to be the same, right? The first line here. So basically over here, fd.weather data is going to be set to this particular weather data object, right? And similarly, we are now going to add this particular forecast object as a second observer in the list. So that means WD.observers will be added as one. We added one more observer over here. Are we okay with this? Okay. In this case, basically every observer is attached to only one single subject, but every single subject has multiple observers. Okay, that's basically the one-to-many pattern you will see in the slides. Okay, one more. Okay, and the third one over here, let's say we use maybe orange. What about this line here? We'll basically create just another one, statistics, right? Using the same WD over here. So statistics also got this make feature over here, and we talk about WD again. So what you will do is SD statistics is going to have its weather data pointing to the same weather data objects over here. And then the third observer for this weather data will be pointing to this statistics. Are we okay with this? Okay, that's how things work together. Now, let's have a look to see how things will work. Especially, let's see this. Now, I say WD.set measurements. Let me use a different color to make sure you see exactly what the changes are. Let's say we got blue over here. WD.set measurements to be some new numbers over here. Okay? So that means we're going to set 9 to 15, and then 75 to 60, and then from 30, also from 25 to 30.4. Okay, the blue ones. That means now what should we do? We should really notify every subject, every observer that's being subscribed to this particular subjects, right? So what we should do is we should really call WD.notified. Okay. So when we call WD.notify, remember how it works briefly. If you look at WD.notify, I'll show you the code. Let's see this. I don't have the code here. The WD.notify, let's review very quickly. It's basically just going to be a loop. Okay, if you look at that, again, notify is defined as follows. You want to go use a cross loop across all the servers and then simply call the updates, right, on that. Okay, that's what you would do. Okay, so now if you try to do notify, it's basically going to run a loop with exactly three iterations since you got 3 observers. For the very first, 3 iterations. For the first iteration, it's going to be WD.observer as an OS, the observers at position 1, and then .updates. Right? That's the first one. And this will call the update from which version? In this case, from CC, right? Current condition, right? Because you know that for the very first iteration, we're talking about this particular green arrow over here, right? Good. Okay. It's going to be CC. I'll just say CC over here. Right? The second one, if you say WD.observers at position 2, again, the updates is going to be, okay, FD, right? Thank you. And, okay, you know the, and then for the next one, OS, observers 3.updates, it should be the last observer, which is the orange link, which is SD. Okay, that's how you notify. So that's why it's guaranteed. After this particular notify, if you try to display for as many times as you like, it's going to display the most up-to-date statistics, right? Now, if you just try another time to say set the measurements again to another data, you really have to make sure you call WD.notify. Otherwise, you will still keep the old copies of the data. Okay? Okay, guys, any question about observer? That's it. Okay, observer. Seems to be not too bad, right? Yes, questions?
Could you call notify every time you call set measurements? Like, could you put notify inside the set measurements?
Sure, you may do that. The question was, could you simply include notify as one of the steps for set measurements? That's true. But in that case, you better make sure maybe notify itself, maybe somehow it's not public. That means nobody else can really call notify but just a set measurement. I would say that's up to your judgment. Yeah. Okay? But it's really important to make sure every time you call notify only when necessary. Otherwise, you lose the point of having this observer over here. Okay, questions about observer? Okay, let's criticize about it. Okay? To help you with the criticism, let's ask ourselves the following question. Okay, let's go to the next one. Okay. Okay, that's about the observer pattern. So everything we have discussed already. So what I would do is I will go to directly to the criticism. Limitation for the observer pattern. Basically, what we discussed for the observer pattern is like a one-to-many relations, right? One single subject and multiple observers, right? What I want you to imagine is we are computer scientists. As soon as we got a solution, we'd like to generalize the solution. What if you got multiple subjects and multiple suppliers? Meaning that every subject can have multiple subscribers, observers. And also, every observer can also got multiple subjects. What would be the complexity really at the runtime? If you think about it. Okay? So now, what I would like to show you is this. Okay, you see what the problem is? Okay? Let's have a look at this diagram over here. You will see exactly what I mean. Okay? And then I will test your knowledge from 2011. Okay? Now, let's say we got a very general scenario, not just a single subject. We got multiple subjects. So every subject is being observed by multiple application or just multiple observers. Every observer may also observe multiple weather data. Let's say it's a many-to-many. Okay. Now, let's say, okay, let me tell you what you need to know, and then you can answer my question. Basically, it's more like a graph, right? What you learned from 2011. Okay. Let's say we got, let's say the number of subjects we have is n. The number of observers we have is n. In general, what would be the worst scenario for having runtime links like this? N times n, right? Okay, it's quite obvious, right? And now let's go a little bit further. Okay, complexity for having n subjects and n observer would just be n times n. You know what this is, right? Okay, I can skip that. Okay, good. Good. Now, question for you. Let's think about, since we talk about design, whenever you talk about design, talk about how can you extend the current infrastructure. If I want to add a new subjects, what's going to be the complexity? New subjects. Let's say rather than having n subjects, I want to have n plus 1. So what would be the complexity for that? What I meant was, what about right here? So adding a new subject, let me use green over here. Adding a new subject over here, that means I'm going to introduce another weather data over here. Okay? In order for me to properly observe this particular weather data, I should make sure it is subscribed to every existing observer, right? That means I got to link this to observer 1, link this to observer 2, link this to observer up to observer n. So that would be big O of n. You want to make sure this particular subject, in the worst case, it has to be attached. It has to be subscribed by all the existing observer, which would be, in the worst case, big O of n. Symmetrically, let's say I have, let's say, adding a new observer. Let's say I just adding a new app. What will be the complexity over here? OM, right? That means you have to make sure this particular new observer should be subscribed to all the existing subjects, right? Okay, so that will be, make sure it is subscribed to this, subscribed to that, and all the way to the last subjects, big O of n. So that's really the criticism about the observer, which means it doesn't really apply so well to a more general design when you got many-to-many relations, when you got many subjects and many observers who actually subscribe to each other. So that's the criticism. So now, how can we improve this? How can we do that? Okay. Now let me just go through some slides, and then we'll see how we can move to the third design, the final design. Okay. Okay, over here, basically in general, we want to have a many-to-many relations to support multiple subjects and multiple observers. And then, okay, you can read this through. It's the same as before. Okay, and now, that's the diagram we just went through. Okay, and then what we really want is event-driven design. Before I talk about what event-driven design really is, let's think about how we can improve the complexity of the diagram over here. Okay? You can see over here, basically what we have is, let me just try to give you some intuition over here. Let's say this. Let's say I got subject 1, subject 2, subject 3. Let's say we got observer 1, observer 2, observer 3, observer 4. Okay, let's see how we can move from the original, the observer design to event-driven design. Let's see how we can do that. It's quite intuitive. Let's just see how we can move the diagram, the complexity. If we got the original design, it's going to be every subject is going to be subscribed to every observer like this, right? That's what we have. Okay, and similarly, that's what we have. The blue one, that's very complex. Okay, now, and we know that, let me just write it again. It's going to be big O of n times n. There is a way to substantially improve the complexity of this design into something big O of n plus n. There's a way. Just by looking at the eventual asymptotic upper bound I want to derive into, can you imagine how the diagram is going to change? Somehow you want to add a median node over there, right? Good. What I really want to do is to say, what if I simply just introduce, let's say, a median over here. I'll just call it M for median. Or you can call it E for events. S1 is going to communicate with the events if there's any updates. S2 is also going to communicate with M if there's any updates. S3 is also going to communicate with M if there's any updates. It does not communicate with each event directly. Similarly, if there's any updates, the media is going to notify the observer. Also, it's going to notify observer, notify observer, notify observer with the median. So can you now compare the complexity between the blue and the pink, right? It's substantially less for the complexity, right? That's how we can get into this particular one. Okay? Guys, makes sense intuitively, right? So basically now, in the case of the weather station, weather data problem, what we want to do is we want to create 3 different events. One event for any updates on the temperature. One event for any updates on the pressure. One event for any updates on the humidity. Basically, that's what we want to do. Okay, that's even better design the observers. Okay, and now I want to show you how you would do this in Java first, and then let's see how we can do it in IFO. Okay, let's see that. Let's see. Okay, that's exactly the event-driven design over here. So we got basically every time you got any subjects, we just publish the updates directly to the events, and now events can be changed on temperature. By the way, you got something very familiar from ETF. Do you notice that? I will try to show you more details maybe next time, but try to, maybe today when you go home, just check on your lab 4, right? For every ETF command class, let's say ETF put number, what's in the last line? Something on change dot update, something like that, right? That's exactly what we are talking about. I'll try to show you more details next time, okay? But something out of curiosity you can see. Okay, it's exactly event-driven design. Okay, so now we're going to say change on temperature and also change on humidity and change on pressure, right? 3 events, okay? Now, and it's going to be n plus n for the complexity, right? As you can see. Now, question for you. If now I want to add a new subject, what's going to be the, let's say I want to add a 1 weather data. Used to be big O of n. What's going to be the complexity now? Just 1, right? Just make sure you communicate to the events. All right? You can see it's much better. And what about adding a new observer? Oh, 1, right? The same. But what can be expensive over here? Let's say if I want to add, what will be the relatively more expensive operation? Let's say now I want to introduce a new measure, okay? Rather than temperature, humidity, and pressure. It's just another measure for the weather data. So what will be the complexity? So that means you can imagine that thinking this way. Let's say currently we only got M1, okay? If I want to introduce another event called M2, so what would be? Well, exactly this way, right? Big O of M plus N. Okay, that's a relatively more expensive operation, but it's still not too bad. Compared with M plus multiplied by N, it's nothing. Well, I wouldn't say nothing, just cheaper. Okay, okay, big O of M plus N. Okay, okay. In an event-driven design, okay, what we want to do now is to see exactly how that works. I'll show you Java code first, and then I'll show you iPhone. Okay, the idea is really the same. Let's just go over this slide here. Let me just read it through for you. Let's read together, and then we'll see how we can implement that in Java. Okay. So each variable being observed over here, we call that monitor variable. Okay, it can be temperature, it can be pressure, it can be humidity. So we got 3 different monitor variables. Okay, what we have to do is make sure. Also, another example could be, so let's say you got a nuclear power plant, right? You have to measure its temperature and also its pressure. If you want to make sure every time, if the temperature measure goes above certain limits, you want to shut down the nuclear power plant. That's exactly the event-driven design that we're talking about. Okay. Now, so now every monitor variable is declared as an event, as we'll see how we can do it. So now we want to make sure every observer, like current conditions, statistics, and forecast, they are attached or subscribed to the events. Okay, and also you want to make sure. One thing to note, you can see in the case of the current conditions, because we only care about the temperature and humidity, we don't worry about the pressure. So you only have to get attached to 2 events only, right? And in the case of the forecast, because we only care about the pressure, so we only get attached to pressure events. Okay? In the case of the statistics, we only get attached to temperature events. So it depends what you need. Okay? You don't have to attach to everything. Okay? And then every time, if you want to notify any updates, you will just notify to the events. Okay? So now, how do we implement that? Okay? The way we implement that, I will let you. So this is the most important part. Okay? Let's just go there. Now, in order to implement this event-driven design, let me just show you something here conceptually. Now, if you look at this event-driven design over here, let's say over here, dynamically speaking, we might have over here, let's say this is current conditions, this is forecast, and this is statistics. Okay? Each one of them should have different updates operation, right? So now here's the trick, conceptually. When we try to subscribe the current conditions to this particular events, what we do is we should somehow subscribe 2 things. One is the current objects. You'll see exactly how to do that in just a moment. If we talk about this particular application, you want to pass the reference for the application. Okay? And then the second one is you want to also pass the updates operation itself. And you can think about the second thing here is more like a pointer to function that you learned in 2031. Okay? Remember in 2031, you can do a star to do the address for the function, right? That's exactly what we're doing here. So rather than just passing the name of the function, we pass the reference to the function for the updates. Okay? So these are the 2 things we want to pass to the events when we subscribe to it. But how would you do this in Java, though? I would say it's doable. That's why I'm going to show you the code. In Java, you can do it, but it's quite a bit of inconvenience. But that's why it's good to know anyway. Okay? In iPhone, you can just use a keyword which you have seen a lot since the beginning. It's called agent. Okay? Yeah, we can see exactly how to do that. Okay, now, conceptually, every time you want to subscribe a particular observer to an event, you have to give the reference to the current objects. You have to give a reference to the updates you want. Okay? But let's see how we can do that. Yeah.
Why can't you just pass the observer that you definitely find called
Because somehow we just want to make sure we don't, when you pass the objects, that means you still have to connect to the observer, right? Which can still be remote. There will still be the connection that's involved. You want to make sure you only pass just once and make sure you don't really have to establish connection again. Yeah, okay. Okay, that's good. Let's see how we can achieve it. Okay, you can read the slides. I'm gonna see exactly, let's see exactly how we can do it by having some code. We are in Java now. We're still in Java, right? So now let's see how we can do this event-driven design in Java. Okay? Eventually, we're going to get 4 classes. Okay, 4 classes in Java. Okay, let's at least learn about the Java ideas, and then we can see how we can do that more conveniently in iPhone. Okay, that's kind of the roadmap. Okay, let's see how we can do. By the way, is it too small for you? Is it too small? Too small. Okay, how about this? Let's not worry about this. That maybe when you study the notes, you can look at that. I try to put everything together. Okay, let's not worry about that. Let's just go over the code quickly. Okay, now let's see how we can program that in Java. Let's go bottom up. Okay, let's first of all define events. Okay, eventually temperature will be events, pressure will be an event. Also, humidity will be events. Okay, let's see how we can do that. Okay, we have a class called events, and then this is really important. We simply got a hash table, and where the key is simply just an object, the most general type you may have. So that means every time when you want to subscribe a particular observer to the event, you simply pass the objects of the observer, and then you pass the method handle. So method handle is some library class you can use. It's more like a reference to a particular operation you have. Okay, and then I simply call it listeners actions. Okay, and then we also got event constructor. We simply just initialize the hash table to be empty, nothing there initially. And then we got subscribe. Okay, what does subscribe really do? Well, simple. Given some listener, some observer, and given some the reference to their methods, we simply just add them into the hash table. Right? Just put the listener and the action into it. Okay, over here, listener and action. Now, what about publish? Publish basically is to say, given a publish over here, I want to see this. So here we simply, if you want to do a particular update operation, you may have some parameters to the updates. So that's why we just say objects over here and arguments. But now, how do we publish a particular updates? The way to do it is like a notify. You want to go over all the listeners and make sure you call that particular updates operation you just store. But how do you do that? Okay. The way to do it is you're going to go over the listeners actions is this hash table here. Listeners.keyset is going to give you all the listeners, right? Objects. And then for every one of them, you're going to basically retrieve the method handle you stored before. And then call that method handle with whatever argument you have over here. Okay? That's basically what you will do. Get the action first, retrieve that from the hash table, and then you will try to say action, which is whatever delay, whatever version of the update you just stored previously. And then you just call invoke with arguments and listener arg. Okay? You can already see quite a bit of complication over here, right? Basically, you want to make sure every time I want to publish the updates, I want to retrieve all the listeners currently, and then whatever operation they actually store when they subscribe to the events, and then try to call them, right? It's a delay execution, okay? Pretty much like what you did in 2031. You can pass the function pointer and call that function later, okay? Okay, that's basically the detail over here, but you can refer to it when I give you the code. Okay, that's about the events. Any question at the event level? That's the bottom level. We'll go bottom up. Okay, let's see how we can, you can see now subscribe and publish are not in the subjects anymore as in the observer pattern. We do the publish and subscribe at the event level, the middle one, the median. Okay? So now what we'll do is, we'll go to the weather data. The weather data is going to be the subjects. Okay? Now for the subjects, we simply got temperature, we got pressure, we got humidity, right? So now we want to make sure over here, basically, the weather data over here, whenever they got any updates, they can simply push their updates onto the events. So that means they're going to declare the events in this class over here. Okay, let's see how we can do that. Okay, so now we got basically, well, I simply use a static. You say public static events. So event is the class we just declared previously, right? So now I can say change on temperature. So that means every time if there's any updates on the temperature, I'm going to publish the updates on this particular events. Okay. Similarly, I also got one event for the humidity. I got another event for pressure. Okay. So far so good? Just 3 events. If you got more monitor variables, you just declare more events. Now, what about set measurements? So what should we do for the set measurements over here? Well, basically, for the set measurements, what you have to do is you want to make sure you publish the updates to every event, right? So let's see how we can do it. The way you do it is by using, so first of all, you want to make sure locally, temperature, humidity, and pressure are simply just up to date. And then you want to also publish, right? You'll simply say change on temperature and then publish. Okay? So what this will do is called the previous publish you just described, and then with the temperature. And then you'll publish to this particular event. It's pretty much like if the temperature is changed, you'll publish to the change on temperature. And there's simply just another event, which is change on humidity, which is also of type events. When there's also a change on the humidity, you also publish the updates to the events accordingly as well. Okay, that's how it works. Okay, what that would do is you can also say change on humidity, the publish as well, the humidity. And finally, you also change on pressure, the publish pressure. Okay? Guys, are we okay so far? Okay, you may have to go over the code maybe after the class, but I just want to give you some big picture. Okay? Okay, let's see the next level. So now we got events, we got subjects. Now let's see how we can do the observer. Current conditions, for example. Current condition is simply just one of the observer over here. Basically, we want to see how we can subscribe to this particular events, how we can do that. So now let's say we simply locally, we got temperature, we got humidity, right? For the current condition, we simply maintain these 2 data. And then let's say the way we update the temperature is simply say whatever temperature you give to me, I'll just assign that. Okay, just update feature, update method. Later on, you can imagine that for line number 3, we are describing a function for updates, but we're going to pass the pointer to this function over here later. That's what we're going to do. Okay. Okay, let's go to the next line. And then also we got update humidity. We can update separately. It doesn't have to be in one go. And then now let's see the constructor over here, right? The constructor is going to work this way. So this is going to be the more details in Java. Okay. Abstractly speaking, you're going to look up the reference for this particular method, and then you want to subscribe this particular method to the events. That's basically what you're going to do. Okay. This is just one of the library classes you can look up. So method handles is one of the Java library, Java API. You can just say lookup, and the method handles are lookup. So now I can use the lookup over here to look up the method itself. Okay, I can simply say method handle, and then I can say lookup find virtual. Again, it's just a method call. You will see that this kind of scaffolding we are trying to build over here in Java, they support this already in iPhone. Okay, it's much more convenient to do so in iPhone. But let's see. Okay, you simply look up. So what kind of information do you have to pass in order to look up the method reference? You have to pass. You may have seen this in 2030, right? Get class. Basically, get a dynamic type for that particular objects. And then you want to pass the name of the method here. In this case, just update temperature over here. Pass the name as a string. And then you will also pass the type of the method. And this is simply the return type because the method itself is a mutator. It is void. And then there's only one single parameter, which is double. Okay? Now, this is how we subscribe. If you look at line number 11, that's how we add this particular observer into the events. We simply say weather data dot change on temperature, which is of type events, right? And then when we say subscribe, we subscribe two things. Number one, this, which is the current object for the observer we're talking about. And then also the method handler, the method reference. So we don't really try to pass the method directly. We just want to delay its execution. So now the consequence is, when we actually pass this particular one, I simply say UT. UT is the just the method reference. When we pass this reference over here, when we subscribe to the events, we don't execute the method just yet. It is only when the events actually want to update the data from the weather data side. We're going to call this particular method. Okay? And then we do the same thing for the humidity, the same thing. Okay? You're just going to do it again. So you can see, in order to do two subscriptions over there, in line number 11 and line number 15, these are the amount of the code you have to write. Okay? Okay, and then that's about the, okay, also you can get display. Any questions until now? Okay? Okay, let's see. Now, let's see weather station. Now, how do we put everything together? So we have seen the events, we have seen the weather data subjects, we have seen the current conditions observer. Let's see how we can put everything together. So now, what we want to do is, let me show you the code over here, and let's see how things will work together. So we got weather data over here. So weather data, again, we got some initial measures, 9, 75, and 25. And then we try to create this particular current conditions app, okay, just CC. And then we try to set the measurements, and then we try to display, and then we try to set the measurements again, and we try to display, right? That's a very simple test, pretty much like how we set it up before. So let's see, I want you to focus on two lines, basically. I want you to know exactly how line number 4 and line number 6 actually work, how the method calls actually happen all together. That's something we want to look. Okay, let's have a look. So what I would do is, let's see this. I'll read out the lines I'm trying to read. I'm trying to highlight for you. Okay, and then we'll go over them together. How much time do we have? A minute. How about start with this, maybe on Thursday, but let me say something about the lab test. Okay, should I? All right, good. Should I say this is actually on the lab test? Oh, okay, yeah.